Hi, I'm Rodney. I am an AP Chemistry student at Bayport High School, and I am presenting on topic 7.9, which is the introduction to Le Chatelier's principle. This video will discuss how adding stress to a reaction through changing pressure, temperature, adding catalysts, or changing the amount of reactants and products will impact the equilibrium. How a reaction responds if the reactants or products are changed. If you stress the reaction by adding a reactant, the reaction's products will increase and the reactants will decrease. And then if the reaction is stressed by a decrease in a reactant, the products of the reaction will decrease and the reactants will increase in order to replace the loss caused by the stress. If the stress is caused due to an increase in one of the products, the response that occurs is a decrease in all products and an increase in reactants. And the opposite happens if you decrease one of the products, the response will be an increase in products and a decrease in reactants. This bottom left graph indicates the stress is where the spike occurs in the graph, and then the stress shows an increase in the reactants, but then ultimately it shows a decrease after the stress is applied. And then once the stress is applied, you can see a gradual increase to then a higher equilibrium with the reactants. The graph right above that one shows a decrease in one of the products. This decrease in the products leads to both products eventually increasing. And after the decrease in the product, it shows the reactants decreasing. This last graph shows an increase in one of the products, which ultimately leads to both of them decreasing. And the one reactant, it shows after the increase in products, it shows that increasing. All right, response when the water is the stressor. When the water is added to a system, it dilutes one of the aqueous equilibriums, which makes the reaction shift to the side with the greatest amount of aqueous species. When one of the aqueous equilibriums is concentrated, it will do the opposite of when water is added, and it will shift to the side with the least amount of aqueous species. The response when pressure is the stressor. Increasing the pressure causes an increase of product production, which consumes the reactants. This can cause the system to shift to the side with the least amount of gas moles. Decreasing the pressure causes the reaction to make more reactants and use more product. This leads to the system shifting to the side with the most amount of moles of gas. Things that are not considered stressors on an equilibrium. There are two things that are not considered stressors because they do not impact the amount of moles. The first one being any excess solid. So if there's already a solid in the system to indicate that it's achieved equilibrium, adding more solids will not be a stressor and it won't do anything. So it is not labeled as a stressor. The second thing that is considered a stressor isn't considered a stressor is a catalyst. A catalyst increases the rate of a system on both sides, so there's never any molar changes, making it not a stressor. Response when water is the stressor or temperature. Higher temperatures consume the excess heat by favoring the endothermic direction of the system, and the opposite happens with lower temperatures. They replace the lost heat by favoring the exothermic direction of the system. In the endothermic reaction, the K value actually changes with temperature, so the K value becomes larger when there's an increase in temperature, and the opposite happens with an exothermic reaction. The K value becomes smaller when there's an increase in temperature. The AP example, it says a vessel contains BaO2 in equilibrium with BaO and O2 as shown by the equation above. Which of the following changes will decrease the amount of BaO2 in the vessel? And you can take a minute to pause the video and figure it out for yourself. All right, so if you thought about it and figured it out, your answer should have been D. D is the case because if you decrease the amount of BaO, by decreasing it, the products will have to increase back up, which will then make the reactants decrease because they'll have to use the reactants to make more products. So the summary of what you should have learned: adding a reactant increases products, taking away a reactant decreases products. Catalysts and excess solids do not impact the system. More pressure equals shift to the side with the least gas moles, less pressure, shift to the side with the most gas moles. Endothermic with increase in temperature is a larger K value, and exothermic with increase in temperature is the smaller K value.